Hello. So we have a function f of x is equal to x cubed minus 12x plus 2. And we're asked to find the intervals of increasing, decreasing, find max, min, etc. So the first thing you want to do is, if you ever need to find increasing, decreasing, max, min, is you need to find the derivative and set it equal to 0. That's it. So if f of x is equal to this, f prime of x is very easy to find. This is just a polynomial, so I can just take derivative of each thing separately. Derivative of x cubed is 3x squared. Derivative of negative 12x is just negative 12. Derivative of 2 is 0. So I have this. And what do I have to do? I have to set f prime to 0. So I'll do that. When you set f prime to 0, what you're finding are the critical values. You're finding values that make the derivative 0, and this is where the max or the min will occur. Okay, very well. So I have to solve this. I have 3x squared is equal to 12. I move the 12 to the other side. Divide by 3, so I have x squared is equal to 4, and x is equal to plus or minus 2. Square root both sides. Okay, very well. So now you have your critical values are plus or minus 2. And now what we do is we draw a number line. We put both of those values on this number line. And what we do now is we check the sign, positive or negative, of the derivative. We want to check if f prime is positive or negative on these intervals. So choose a value inside each interval and plug it into f prime. Okay, so let's do that. So if I take a value between negative 2 and 2, the easiest one I can choose is 0. So what we'll do is we'll look at f prime of 0. F prime of 0 is negative 12, which is less than 0. It's negative. So because it's negative, what we do is we say this is decreasing. And I'll draw a downward arrow. So our function is decreasing on this interval. Why? Because the derivative is negative. Okay. We'll explain, we'll show a picture of why, if the derivative is negative, why does that mean the function is decreasing? But we'll explain that in a different video. Okay, so now let's check this interval. So choose a value somewhere over there. Don't choose 2. If you choose 2, then f prime is just going to be 0. So it won't give you any information. So let's choose, say, 3. Okay. F prime at 3 is equal to, well, it's 3 times 3 squared minus 12. That's 27 minus 12, which is positive. Okay, I don't need to know what the number is, I just need to know if it's positive or negative. Because it's positive, it's increasing on this interval. Lastly, check over here, choose a value like negative 3, and you will see that it's increasing. Don't take my word for it, choose a value, plug it in, and see that it's true. Okay, once you have the interval done, and you have the intervals of increasing, decreasing, etc. Now what we can do is we can actually write the interval in interval notation. So f is increasing on, okay, so where is it increasing? Well, it's increasing from negative infinity to negative 2. I put parentheses on both, and it's also increasing from 2 to infinity. So what I'm going to do is I'm going to put union 2 to infinity. Union means or. So the function is increasing on this interval or this interval. Okay, very well. Similarly, f is decreasing on, it's only decreasing on this interval, negative 2 to 2. Okay? The max, or the local max, rather, it's local because the derivative changes sign. So they call that a local max. Double check with your professor, your book, or your notes. Some books call this a different name. But the maximum or the minimum where the derivative changes sign, that there's a special name for that. In our book, we call it the local max. Anyways, local max. Okay, so now we have to think about this. We want the maximum, which is the highest point. Where is that going to be? Well, the function goes increasing, 0, decreasing. So that's a maximum. So there's a local max at -2. And the function at 2 goes decreasing, 0, and then increasing. So there's a local minimum at x equals +2. So what you just found, the intervals where your function is increasing, decreasing, and you found the local max and min. Let me see if there's anything else we need to do. They do want us to find concavity and inflection points, but we'll probably not do that because I don't feel like it. See you in the next video.